Now we have provided one circular ring of radius small r, and we have been provided that it has been divided into two parts. One part is PRQ and another part is PSQ. So if we are simplifying that figure, we can say that PRQ and PSQ, but the condition is that PRQ and PSQ both will have a different qualities. Just like resistance for the PRQ is going to be R1, for its length is going to be L1, and angle as shown in the figure is theta. Complete circle will form 2 pi, that's why the remaining angle will be considered as a 2 pi minus theta. So for PSQ, resistance is R2, length is L2, and the angle is 2 pi minus theta. Now if we are observing PRQ and PSQ, both of them are parallel to each other, and that's why the equivalent resistance is going to be 1 upon R dash is equals to 1 upon R1 plus 1 upon R2. Now first we have to evaluate the values of r1 and r2. For that we have to consider the values of theta. Now what is theta? Theta is equals to arc upon radius, so we can say that theta is going to be L1 upon r, just because the first portion has a length of L1 and the second portion has a length of L2. So theta is equals to L1 by r, and that's why we can say that L1 is equals to theta into r. Similarly for the second case, 2 pi minus theta, so 2 pi minus theta, that is also equals to arc upon radius, and for that the length is L2. So we can say that L2 is equals to 2 pi minus theta into small r. And if we are accepting that it is a complete wire, its length will be considered as a 2 pi r only. Now we have a equation for the resistance R is equals to rho L by A. So for a complete circular ring, the resistance is going to be rho 2 pi small r upon capital A. For the fragment PRQ, it is going to be R1 rho L1 by A, that is equals to rho theta small r upon A. And for the portion PSQ, it is going to be rho L2 by and rho 2 pi minus theta into small r, just because L2 is equals to 2 pi minus theta into small r divided by A. Now we are going to put these values in the equation. 1 upon r dash is equals to 1 upon r1 plus 1 upon r2, just because both of them are parallel to each other. So we can say that 1 upon r dash is equals to A upon rho theta r plus A upon rho 2 pi minus theta r. A upon rho are common, so 1 upon theta plus 1 upon 2 pi minus theta, bracket completed. Taking LCM, we are going to 2 pi have the equation as 1 upon r dash is equals to A upon rho r 2 pi minus theta plus theta into 2 pi minus theta. Now theta cancel, so 1 upon r dash is equals to A upon rho r, that is equals to multiply by 2 pi upon theta into 2 pi minus theta. So we can say that r dash is equals to rho r theta into 2 pi minus theta upon 2 pi A. But from this equation, r is equals to rho 2 pi r by A, we can say that rho r by A is equals to r upon 2 pi. So rho r by A, that is equals to r upon 2 pi. We are going to put that value here, so we get the equation that r dash is equals to r theta 2 pi minus theta upon 4 pi square into A only.